Now let's try our factorising skills to the test. If we're given a random expression, the first thing to do is to try and sort of take out a common factor, or the highest common factor. Okay, always. It's sort of like an automatic thing. Is that you'd see a random expression, always try to factorise sort of a common, or apply common factorisation first. The next thing we try and do is identify the type of expression that it is. And hopefully it's sort of one of these types of expressions. That could be a difference of two squares. The factorisation of which is, be a, if it was a squared minus b squared, it would be a minus b, a plus b. Okay, so they're those sort of those conjugate binomials, a product of the two. Could be a monic quadratic expression, so in the form x squared plus bx plus c. We try and find two numbers that multiply to give you the c, but when added together gives you b. Okay, could be a non-monic quadratic expression. So this is in the form ax squared plus bx plus c, and we could either apply, there's two methods we can apply there. We can either apply the cross method, okay, if you remember that, or you can try and find two numbers that when multiplied together gives you the product AC, but when added together gives you B. And then you can apply the grouping in pairs method to split up the middle term. We've also got quadrinomials, right? So these are the expressions that involve four terms, and this is just one such example. So we can group, just group the first two terms and the last two terms, or if we need to switch a couple of terms around to make it factorizable, but when we group it in pairs, then by all means do that. Okay, you may find that it might be none of these. In fact, the expression may not be factorizable at all. So if that's the case, then that's it. There's not much you can do. If it is one of these, then you just apply the correct factorizing method and make sure that you factorize fully, and also make sure that you simplify the expression fully as well. Okay, it's anytime you're asked to factorize or simplify, it's always assumed that it is fully factorized, fully simplified. If not, there's a good possibility that you may not get or may not gain all the marks for that question. Okay, so let's have a look at some examples. Okay, so at this point, if you like, you can pause the video, have a go at some of these examples, unpause the video, and then just check your work solution. So let's have a look. So 3x squared plus 15x minus 72. The first thing we do is we try and take out a common factor if we can, or the highest common factor. And in this case, we can take out the 3. In fact, this is a non-monic quadratic. At least on the surface, it appears to be non-monic. We could apply directly. We could apply the grouping, not the grouping in pairs. Sorry, either the product of 3 and 72, and try and find two numbers that that multiply to give you that, or add to give you 15, or use the cross method. So we try and avoid those kind of methods if we can, if possible. So let's take out the 3. Hopefully we can turn it into something that's a little bit simpler. And that's always the idea, isn't it? So let's take out the 3. So we have x squared. So dividing everything by 3, we have x squared plus 5x minus 24. That's a little bit better. I'm thinking, I have to use the cross method or the grouping in pairs method to solve, or to factorize this quadratic. If you have to use that, then fine, but we try and avoid it where we can. It's a lot easier doing it this way. This is a monic quadratic, so try and find two numbers that add up to give you positive 5, but then when multiplied together gives you negative 24. So I can think of positive 8 and negative 3. So x plus 8, x minus 3. Check to see if that works, of course. So if we just multiply those two brackets together, x times x gives you x squared, x times negative 3 gives you negative 3x, plus 8x gives you 5x, and then positive 8 times negative 3 gives you negative 24. And then the whole thing is being multiplied by 3, so you just triple everything and everything's fine. So I think we're happy with that. So look at part B. 5ab plus 15bc. Okay, again, try and take out a common factor first if we can. So we can take out a 5. We can also take out a b as well. So let's see what's left over. So we have an a plus c. And there's really not much else we can do with that. That's it. As far as we can go with that. let's have a look at C. Okay, C sort of looks quadratic. Can we take out a common factor? Oh, no. Or ny squared and mx squared, there's nothing in common there, so we can't take out a highest common factor. There's 4 terms, it's a quadrinomial, isn't it? Okay, so it might look quadratic because of all the squareds, but there's actually 4 terms there. So let's try grouping it in pairs and see if we can let's see if we can factorize it that way. Now the first pair of terms, mx squared minus ny squared, there's nothing in common there, so that's a bit of an issue. So maybe if I swap 2 terms around, so what if I swap these 2 around, and I might be able to have something here which can be grouped in pairs. So mx squared plus my squared, yeah, minus ny squared minus nx squared. Let's see if we can work this out. Sometimes you may have to give things a go maybe twice, or attempt to, maybe have 2 attempts at it to get it right, and that's fine. Let's take out m. Okay, it's a common factor there, and we have x squared plus y squared. Okay, that's okay. Then we can take out minus n from the next 2 pairs, and we end up with x squared plus y squared. Notice that I've switched the x squared and the y squared around. I can do that. Because I'm taking out a negative n, you end up with y squared plus x squared in the brackets, but y squared plus x squared is the same as x squared plus y squared. Now with addition you can switch terms around. Okay. Now clearly I have a set of brackets here that are identical. Okay, so I can take that out as a common factor. So x squared plus y squared, and m minus n is left behind. Okay. Right, let's have a look at part D. Okay. Again, first thing we do, what do we do first? And you're thinking, take out a common factor. If you've said that, well done. All right. If you haven't, well, this is something to get used to, okay? So you see an expression, the first thing, right? Common factors. Take out a common factor. Always the first thing we do. It looks kind of quadratic as well. Well, you can see sort of squareds there, and there's an x squared and a y squared, and it's anyways. Well, let's see what we can do with this. All right. I think there are some common factors we can take out. We can definitely take out a 6 because 6 divides 12. 6 also divides 48. We've also got, looks like an xy term in all of these terms as well. So I've got a y there, there's a y there, there's an x. Okay, well, let's take out a 6xy. Okay, and let's see what's left behind, sort of the remnants, okay, that are left behind in the brackets. So 6x squared y, if we divide it by 6xy, we end up with x inside the brackets. Now 12xy squared, okay, we have a 2, so plus 2. We've taken an x out, but there's 2 y's, y times y. One of the y's is already outside, and one of the y's is left behind inside. Okay, so what you can do is, as you factorize this and you start to work out what's inside the brackets, you can multiply it back and make sure you get the term that you start off with. So 6xy times x is 6x squared y. Agreed. 6xy times 2y is 12xy squared. Yeah, that's fine. And what about negative 48? So there's 8 of those, isn't there? So we've got 8 times now 6, or 6 times 8 is 48. And then you have xy. Well, we've taken the xy out already. And that's it. The other thing to check as well, apart from multiplying it out to make sure that you get the original expression, is to make sure that what's left behind in brackets is fully factorized. Okay, so make sure that, if you don't do this properly, or if we don't do this fully, then I might just show you an example of this. So I guess, to the uninitiated, or maybe to those of you who don't, lacking a bit of practice, your initial instinct might be to think, these are all even numbers. So how about I take out a 2xy? Okay, so let's say we did this. So take out 2xy, okay, and then what you end up with 3 times as much. You end up with a 3x, okay, plus 6y, okay, plus 24. Now you might think, oh, okay, that's factorized. But inside the brackets, you can still take out a 3, right? This 3 can divide the 6 and also divides 24 as well. So this is not fully factorized. Okay, I just really want to make a point of this. Okay, because this is an error that I see, I have seen in the past, and I guess it's just when you're under exam pressure or under pressure in an assessment task, you forget that it's meant to be fully factorized, and it might seem like a very, very easy error, or I might think like an error that's too easy to make, but these sort of errors do happen, okay, and it can happen to the best of us. So just be mindful of that. All right, let's have a look at some other examples. Okay, so 6x squared, so I'll just fix that. Yep. Okay, so 6x squared minus 33x plus 45. So again, first things first, let's try and take out a common factor, or try and take out the highest common factor. On the surface, it looks like a non-monic quadratic again. All right, so can we take out a common factor, or what is the highest common factor here, apart from 1, of course? We can take out a 3, can't we? 3 can divide 6, 3 divides 33, 3 also divides 45. So why don't we do that? So let's take out a 3. It's a bit like that first example, isn't it? All right. And what does that leave behind? That leaves 2x squared minus 11x plus 15. Okay. So at this point now, what I've done is I've reduced a larger, I guess, non-monic quadratic, at least with larger coefficients, to a non-monic quadratic which has smaller coefficients. Now we could either apply the cross method at this point, or we can apply the grouping in pairs method, where you split the negative 11 up in such a way that the sum that you come up with, the product of those two terms should equal 2 times 15, which is equal to 30. So maybe given the limited space, I might not use the cross method here. I might just use the grouping in pairs method. So leave the 3 there. Okay. So try and find two numbers that when you multiply the two numbers, okay, I might just write this off to the side. Multiply the two numbers, right, you get 30. But when you add the two numbers, right, you get negative 11. So these are the two numbers A, B that I'm talking about, A and B. Well, two numbers that multiply to give you 30, you got 5 and 6, right? That 5 times 6 gives you 30. But negative 5 times negative 6 also gives you positive 30. But then when you add negative 5 and negative 6 together, you get negative 11. So I think we're happy with that. So end up with 2x squared, okay, minus 6x. I might have to be careful which order you do this. Minus 5x plus 15. I've got it around the right way. Yep. Now you can apply a grouping in pairs method. So I might just squeeze it in there. Okay. So 2x squared minus 6x. Okay. You can take out actually 2x as a sort of a common factor here. So we can factorize the first two terms there. If you take out 2x, okay, and that leaves x minus 3 in the brackets there. Okay, and what about 5x minus 15? Okay, so we can take out probably negative 5, okay, as well, and you end up with x minus 3 in brackets there. Okay, now we can, in fact, I'm just going to just this part G, so I've just run out of space here, so I'm just going to write part G here. Again, because I just need an extra line of working out. Yep. There you go. Problem solved. Okay. So writing down this solution, the 3's on the outside, so that stays where it is. And you have x minus 3. Okay, that's our common factor inside the brackets, and 2x minus 5 as our solution there. Okay, if you multiply that all out, you should end up with 6x squared minus 33x plus 45. Okay, so I think we're happy with that. If you've used the cross method, you should end up with the same answer, okay, or the same solution. All right, let's have a look at part F. 1 minus a to the power of 4. Now again, on the surface, it doesn't look like anything. We can't take out a common factor. It doesn't look like a difference of two squares. Doesn't look quadratic, doesn't look anything, right? However, I think we've seen an example like this before in one of the previous videos. A to the 4 is just a squared squared. So I'm just going to write this again. That's really 1 minus a squared all squared. So changing the form of it to make it look like one of those forms that we looked at the start of the video definitely goes a long way to helping to factorize this. So we now have a difference of two squares. So let's factorize it using that. So that's 1 minus a squared outside of 1 plus a squared. Okay. So the terms inside the brackets of the binomial, it's just a square root of the original term. So square root of 1 is 1. Square root of, in fact, square root of a to the power of 4 is a squared, in fact. Is that fully factorized? And if you've said yes, think, oh, hang on a moment, look again. Look at the first binomial there. That's in itself a difference of two squares, which needs to be factorized one more step. So that's 1 minus a, 1 plus a, 1 plus a squared. Okay, so if you've said, no, it's not fully factorized, well done. All right, you've seen this, that's for full marks. What about h? 12x minus 6y plus 2mx minus my. Can you take out a common factor? No numbers, no pronumerals. So no common factors can be taken out. Doesn't look like anything, doesn't look like a quadratic. There's certainly not a difference of two squares. It's a quadrinomial, it's 4 terms. Now, we could probably just keep the terms as they are. If you want to switch terms around, you're welcome to do that. I don't think we're going to gain anything by switching terms around. Okay, I know we did that in one of the other examples because we kind of had no choice. But in cases where you have a choice, just leave them as they are. And I usually always find that leave the first term intact, leave the last term intact. If anything, just switch basically switch the two middle terms if necessary. Let's just group them in pairs. Okay, so you've got 12x minus 6y and factorize that. Okay, so 12 and 6, we can take out 6 and you end up with 2x minus y. Okay. Then you've got 2mx minus my, so we can take out an m, so plus m, and that leaves behind 2x minus y. Make sure that when you multiply it out, now I'll sort of do these checks subconsciously, I guess. M times 2x is 2mx, m times negative y is negative my, 6 times 2x is 12x, 6 times negative y is negative 6y. So far so good, so we're happy with that. You can see that we have a common factor here of 2x minus y. That can be taken out, okay, leaving behind 6 plus m, okay.